Hey everyone, my name is John Voth. I'm a grad student here at the Mechanical Energy and Power Systems Lab. And today I'm excited to talk with you a little bit about a new type of hydraulic motor that we've been working on in the lab for a few years now. So the main motivation behind this motor is we looked in industry and we saw that there's potential for energy saving if we were to take a low speed, high torque motor and make it continuously variable displacement. So that's exactly what we've been doing over these last few years. And this is our Generation 1 prototype motor. So the way that it works on the inside, if we can open it up, you'd see something that looks like this. Now, what I want you to focus on is this red subsystem, which is the linkage, and it is a 7-bar, 2-degree of freedom mechanism that is adjustable. So as you adjust a virtual ground pivot, which is basically doing this, then that translates into a continuously variable stroke of the piston, and that's what gives us the variable displacement motor. So we employ this technology on the inside of our motor, and we have a functional Generation 1 prototype. So we just finished experimentally testing it and validating all of our models, and right now we are all hands on deck designing the Generation 2 prototype, which is going to be about 40% smaller than this, but have all the same or actually improved performance.
Hi, my name is Jake Larson, and I'm a grad student in the Mechanical Energy and Power Systems Lab. This apparatus that I'm standing in front of today is an accelerated piston side load wear test setup. So the goal here is to test what allowable piston side load wears are between cylinders and pistons. So our Generation 2 variable displacement linkage motor had the goal of being smaller in diameter. Well, that reduction in diameter has increased the side load forces. So that is the force of the piston being forced into the wall of the cylinder. So as the piston moves in and out, you'll create wear on the outside of this piston. And we predict it's going to be barrel shaped. Well, as the piston wears, we're going to get degraded performance through the life of the motor. So we want to determine what is this wear rate? What is the acceptable side load forces that we can have? And using models, determine what the life of our Gen 2 VDLM will be. And then drive decisions such as improved materials, coatings, or different designs. So how we are testing that is we have an insertable piston and cylinder assembly that goes into this block, and we are pumping hydraulic oil through it and oscillating the cylinder back and forth with the piston, and through a setup of 5 minutes, half an hour, 2 hours, we will run the piston and cylinder and then measure them using a profilometer that has micron level accuracy.